So today we're going to review product rule. The first thing we're going to start out with is the rule itself in case you were a little confused. We'll call the function p of x, and it's any time you have a function times another function. The derivative, and the two ways to write the word derivative in symbols is dp dx. That is the derivative of p with respect to x, or we can write p primed of x. And for the derivative of the product, you will take the very first function, leave it alone. You will multiply it with the derivative of the second function, plus leave the second function alone, multiply by the derivative of the first function. So I have an example down here, and remember in class, what I say for you guys to do is do a little side work. Find the derivative of the first function. So we want to clarify that this is definitely a product rule. There are your two functions. This is called f function. This is called g function. And then on top of that, I'm actually going to rewrite x to the 1/3. That's actually the function. So my derivative I'll do in pink. The derivative of x to the 1/3 is 1/3 x to the negative 2/3. How did I do that? I did a product rule, a power rule. The power was 1/3. I bring that down to the front. That's here. And then the power of 1/3, I'm going to subtract 1. So 1/3 minus 3/3 makes negative 2/3. The derivative of the second term is just 2x plus 0. Constant 4, the derivative of 4 is 0. So now the derivative of this problem, and I'll do that in purple, is equal to, leave the first one alone, multiply by the derivative of the second, plus leave the second one alone, times the derivative of the first. And the derivative of the first was 1/3 x to the negative 2/3. All right. In terms of simplifying this, it really wouldn't simplify much at all. But what I will do is simplify what we can. This power of x is a 1. So the 2 comes out front. X to the 3/3 plus 1/3 makes 4/3, because we're going to add the powers when there's both the same base. Plus 1/3 x to the negative 2/3 plus 4. I'm going to actually keep that in factored form. And I'm just rewriting it. I actually switched the order in which I wrote it, but if you want to leave it the other way around, these are reversible. Next problem. We are going to do the quotient rule. Just to remember how to do it, our quotient rule, q of x, is equal to a function on top divided by another function on bottom, and this is our little mnemonic device, low d of high minus high d of low all over low squared. So the derivative of this function, and I'm going to move our problem down a little bit. The derivative of our function q, so anytime you want to take the derivative of a quotient, you take the low function times the derivative of the high function minus the high function times the derivative of the low function all over the low function, whole thing squared. So we're going to deal with the problem down there, and I like this problem because it has coefficients and constants that are not variables, but they're not values as in numbers. So what I'm going to do is find the derivative of my numerator, and the derivative of a constant is 0, so this b, the constant value, the derivative is 0. It's a constant. The derivative of the numerator is a, and the derivative of the denominator is c. If you're having trouble with that, the reason why, if you have a to the x, the power of x is 1. So we would drop the 1 in front and multiply. So it would be 1 times a times x to the 1 minus 1, which makes a power of 0. X to the 0 is 1, so you get left with 1 times a times 1, which is just a. That's why we have just a. All right, here we go. Finally, y prime. Low, d of high, minus high, d of low, all over low, low, which is squared. The numerator, let's see if this simplifies at all. A times c times x minus a times d minus a times c times x minus bc all over cx minus d, whole thing squared. And let's see if that can be simplified at all. It looks like those cancel if I didn't make a mistake. I'm really going to hope I didn't, but I get negative AD minus BC all over CX minus D squared. So how can you get a quotient rule wrong? You forget that the quotient rule starts with the low. You forget that the quotient rule has a minus sign in between. Those are two major mistakes. And remember that that minus sign means that we're going to have to make sure that this here somehow has parentheses. Okay? You're distributing your negative. So I have, I think, one or two problems. This one was a problem that we had on, I think, worksheet 3, maybe. I'm going to squeeze that right here. I'm going to do C and D because they had, well, I guess I can do B, C, and D. So letter B, y is equal to 2x over g of x. To me, I can tell that this is a quotient rule. The top derivative is 2. The bottom derivative, it's a function. So we literally just write g primed of x. I don't know what g of x is, so I can't officially find the derivative. So I have to write that the derivative of g is literally just g primed of x. So now I'm going to write that I'm doing y prime equals low, regular g of x, d of high, 2, minus the high function, multiplied by the derivative of low, all over low, low, which is low squared. That really doesn't simplify much at all. The simplified version would look like 2g of x minus 2xg primed of x all over g squared of x. That's another way to write g of x squared, kind of like when we do sine and cosine. Let's see, and I'll do part C here. I'll do that in purple, I guess. Part C, y is equal to x squared f of x. So this is a product rule where function 1, or the first function is x squared, and function 2 is that f of x. Derivative of the first term is 2x. The derivative of the second term is f primed of x. So given all of that, we can now find that y prime is, leave the first function alone, multiply by the derivative of the second, plus leave the second function alone, multiply by the derivative of the first. So without any mistakes, hopefully, we get x squared f primed of x plus 2x f of x. Part D, I'm going to have to do on a different screen. So let me copy that problem over, just because I ran out of room on here. All right, and we have, hopefully I can get all of this to fit in within a certain amount of time. All right, there we go. So the top of the function is 1 plus x times f of x. So there's actually a product in there. Down bottom, I'm also going to find its derivative. Let's start with the bottom just because it is easier. Another way to write root of x is x to the 1/2. So the derivative, 1/2 x to the negative 1/2. The numerator, the derivative of 1 is 0. So I'm actually going to even write that for you, 0. Plus the derivative of the second function, x times f of x. That's a product rule. So x, f of x, that's a product. What is it a product of? X times f of x. So the derivative of x is 1, and the derivative of f x, f primed of x. So the derivative of the second term here, x, f of x, would be, leave the first one alone, derivative of the second, plus, leave the second one alone, times the derivative of the first, which is 1. So I'm actually not going to write it. That is a derivative of the numerator, the entire top. The 0 we don't have to worry about. Okay, so y prime would equal low, oopsie, low, and I'm actually going to write it as x to the 1 half. Low d of high minus high d of low all over low, low. Looking at the numerator, I'm going to see if there's that much to simplify. I'm going to say there probably isn't too much. Let's see. I will multiply out the numerator. So if I multiply x times this term, that's x to the 1. So we're going to add the powers 1 half plus 1. That would be x to the 3 halves, f primed of x, plus x f of x. And this minus sign, we can take care of the minus by distributing into the first set of parentheses. So I'm going to make that a negative 1, and I'm going to make that a negative x f of x. That way, you guys kind of don't forget about that minus. So I have negative 1 times 1 half x to the negative 1 half, and I have negative, that was this one, and negative x times that, so we get minus 1 half x to the 1, x to the negative 1 half, so that's x to the positive 1 half, f of x. How did I get that? I took x to the 1, subtracted 1 half, because I'm literally adding the powers 1 plus negative 1 half. So 1 plus negative 1 half. That gives me positive 1 half. All over x to the 1 half squared. That literally would give me x to the first. So that is probably as simplified as this is really going to get. There isn't much more I can do with it. Last problem for this set. We are looking at the one that you guys had on worksheet 3, I believe.
Good afternoon.
Sorry about the announcements. We are doing, I think this is from worksheet 7, or worksheet 3, it's number 7. I'm really sorry, but it looks like the axes had moved when I printed it. These are the actual axes, okay? So we are looking at p of x is a product function. So let's do part A over here in red. P primed of 2. How do we find the derivative of a product? We do leave the first one alone, multiply by the derivative of the second, plus leave the second one alone, times the derivative of the first. So if I want to find p primed of 2, you will get that you're supposed to find f of 2, you're supposed to find g prime of 2, you're supposed to find g of 2, and f primed of 2. So what do all these little things mean? So let's do f of 2. F of 2, the f function is that top function. We're going to go over to 2. This point right there, the y value is 3. So f of 2 is a y value, and that's 3. Now I'm going to do g primed of 2. Well, g primed of 2 is a little bit harder. Here's g, right here. And g primed means I need to find the slope at 2. Well, it's nice because it's a line, so you can easily find the slope of a line. So I can go up 1 over 1, 2. The slope of that pink line is 1 half. So we're literally going to multiply it. Then I'm going to put the plus back. Then I'm going to look at g of 2. G of 2, that's the y value. So that is literally 2. How did I find that? I did not do a slope. I just found the y value. And then the last piece there, you have, I'll use purple, f primed of 2. I would go to 2 and find the derivative, which means slope, of the function at that point. Well, that is a horizontal tangent. So the derivative there is 0. The answer to this, p prime of 2, is 3 halves plus 0. So it's 3 halves. I'm actually going to stop it there. I think q of x is now a little bit easier because you understand the concept. Anytime you're asked to do like f prime of x or g prime of x, you're doing slopes. And when you're asked to do something like g of x, I'll do that in black, or f of x, you're doing y values.